Today's notes are going to start with the plant kingdom. So there's your heading for this chapter. Plant kingdom. Characteristics of plants. Go ahead and make this a subheading and list those three things. Characteristics of plants. They have many cells. Okay, plants are going to be multicellular. They're never going to have a one-celled plant. Many cells. They have chlorophyll for photosynthesis, so stuff that makes them green, that allows them to turn sunlight and carbon dioxide and water into sugar that they can use for food. And then plants are going to have cell walls. Each of their cells are going to have a cell wall. It's kind of a rigid structure that gives it shape. Okay? The reason your tree in your backyard doesn't just flop over, okay, is because it has many cell walls working together to hold it up. If I am going too fast, you can always pause. A couple other things to add to this. Plant cells are going to have a nucleus. They are eukaryotic. Plant cells are eukaryotic. They have a nucleus. And then most have roots. Most, some sort of root. Most of the time it's to suck up moisture, but it also kind of anchors the plant down, holds it in place. Even something like seaweed, okay, it doesn't really need roots to gather water, but it needs to anchor it down, otherwise it's going to float around. Kind of some history here. I would write this down. This actually answers one of the questions from the last chapter's web quest, I believe. Go ahead and write this down. First plants were probably in water, evolving from algae. So the idea was algae is a super simple little critter floating around in water, and from there on it evolved into our modern day plants with roots and making its own food and all that stuff. You don't need to write this. How do plants conserve water? Worry about that. I would like you to write this down. A cell wall provides support even when the plant has little water. Normally plant cells, and all cells, including yours, are plump with water. They're full of water, okay, and that also kind of helps it give it shape. Okay, if you think of like a water balloon, has a pretty round shape when it's full of water. Okay, well, if a plant is low on water, the cell wall is still going to support it. You've maybe had a plant in, whether you have a garden or just a potted plant that looks wilted, okay, and then you give it some water and it, within a couple hours, it plumps back up, okay. Its cells were low on water, so basically it was like that water balloon was like half full or partway full, and then once you give it some water, it fills back up. Now that plant still was able to hold itself up because of its cell wall. I also want you to write this down. A waxy cuticle on most plants, leaves and stems prevent water loss. A waxy cuticle on most plants, leaves and stems prevent water loss. So you really can notice this on like cactuses and stuff, is they're really like almost rubbery on the outside. What that is this waxy cuticle that locks in moisture, okay? Even like your trees outside, your maple trees or whatever, the outside is kind of waxy, kind of slick, okay? That waxy cuticle is trying to prevent as much water loss as possible. Because on a hot day with the sun out, it's going to suck moisture out of the plant leaves and stems. Don't write this. Write this. Wait a second. Actually, go ahead and write this. Sorry. Vascular plants have vessels that carry water and nutrients throughout the plant. Vascular means tubes. So vascular plants are usually big plants, like the tree in your backyard, okay, that have tubes that are going to carry water and nutrients around the plant. Vascular tissue means veins. This is a piece of celery, and maybe you've seen this before. Okay, you can actually see the little tubes there. Okay, and those tubes are going to carry moisture up. You might maybe have done something in elementary where you put a piece of celery and some food coloring, and then the leaves turn colors. Okay, it's because it's drawing water up those tubes. If you've ever bitten a piece of celery and there's like some strings hanging, those strings are the tubes. If you count the rings on a tree, okay, you count the rings on the tree to see how old it was, okay, well, you're counting vascular tissue. Every year, as the tree gets bigger, it adds a ring of vascular tissue, tubes, veins, that are going to help it suck up water and nutrients. On the other hand, go ahead and write this down. Non-vascular plants do not have vessels. They are usually very small, like moss. You've seen moss on the side of a tree or a building or something. It doesn't get very high. What happens is these plants don't really have roots that suck things up. They don't have big transporting vessels because they don't have to go very far. Okay, the big oak tree in your backyard maybe needs to take water like 100 feet in the air. That's a long ways. With these plants like mosses, these non-vascular plants, they live in wet areas. Okay, they don't need to transport stuff. So what I need you to know is vascular means vessels and veins, non-vascular, no vessels and veins. Nothing right here, but here are some common plant phylums. Okay, you probably haven't heard of many of these. Conifera, which is conifers, trees with cones, angiosperms, flowering plants. There we go.